Hi, my name is Hurst, and I will be doing another 6-minute thermodynamic topic on pulse jets. Just a brief overview of the presentation. Go through an introduction about what exactly a pulse jet is, how it's defined. Then talk about the different types, valve versus valveless. Give a couple examples, got a couple pictures, just talk a little bit about those. About the relation it has to thermodynamics, and then I have my list of references. So what is a pulse jet? A pulse jet is just a jet engine that instead of having a constant combustion process going on, it occurs, it pulses, just like the name says. The picture I have shown here is of a valve pulse jet, and it has the black line. Here is the ignition source, and it's also where the blue arrows are indicating the airflow entering the combustion chamber and the fuel mixing with air, and then spark combustion right here, and then creating the thrust. The two types, like I said earlier, we have valved and valveless. Right here, the advantages to valve it's got a much higher power to weight ratio, and it's also easier to integrate into remote control airplanes, cars, whatever an enthusiast is looking to do, because most of these engines are just home projects that people make in their sheds. Disadvantage, it's only a disadvantage really compared to the valveless pulse jet, and that it has the one moving part, and it's generally what people use is a reed valve. The way that works is you have these two plates that can only be lifted one way, so that whenever the fresh air is entering, they lift up and allows the air in, but then whenever the combustion occurs and the air tries to leave through the intake, the reeds close and it keeps it all air, forces it all out. And that's one of the reasons why it gets the higher power weight ratios. You're not losing the thrust out of the intake as compared to the valveless. Another advantage, because you need the valve, it's a little bit more difficult to actually manufacture, but it is what a lot of people end up using. For the valveless, all right, the advantage, like I said, the exact opposite of the valve is there are no moving parts. It also has an extremely wide range of throttling, basically just almost no limit to how much you can put through it. You can also use just about anything to fuel it. Most people use propane just because how widely available it is. You can set it up, it comes in a tank already and everything. You find all of the parts that you need for that, and they are much easier to design because of the lack of the valve. Disadvantage, they are much harder to get a higher efficiency. Most people, the way it goes for most people is generally the larger the pulse jet, the more inefficient it is, and also the lower amount of pulses per second. Whereas you can get for a small valved pulse jet, you can get upwards of 100 pulses per second, or at least on the order of hundreds. And for the, whereas if you had a large valve or a large valveless, you're looking at only around 40. Here's an example of a valve, and it's actually attached to a remote control airplane. You have your spark plug for your ignition source. There's your intake. This is a little black hole right here. This red piece is the actual where the valve is contained, and you have the fuel line coming in here. And then you have the combustion chamber and the nozzle. For valveless, this one's actually running, and as you can see, it's getting pretty hot, and basically they just get really, really loud and then really hot. And if you don't really know what you're doing, you're just going to have a big noise maker. attached to whatever you're putting it on. You can see they're using propane here. It's basically like they just set up a burner and then just toss a piece of metal on top, and it's just heating it up. This is it's a valveless, two valveless pulse jets actually, attached to a golf cart, or a go-kart, I guess you can call it. And they actually tested it, and it gets about 400 pounds of thrust. Pretty decent. They said it only weighs about 150 pounds, so it'll get you going a little bit, but like I said, there are better options. All right, for thermodynamics, the process, it's related to the Otto cycle. It's much less known than the Lenoir cycle. It's just what's used for pulse propulsion. It has lower efficiencies than the Otto and diesel cycles. Here's the graph. Since it doesn't have a piston for compression, you lose the one step in the process, but you have this is where the air and fuel is heated, where it's thrusted. It's heated through the throttle and everything, and then thrust is created right there. Any questions? Yes.
I wanted to know that do they use this kind of jets in professional digging applications? Just so you can make it backyard and those things?
They were the first ones. It's believed that these are one of the. His question was, do they use this anywhere besides just side projects? They actually use them on rockets. They used to use them for military rockets, some of the valve ones.
So do they have advantages over traditional jet engine?
The advantage, not really an advantage, and that's why they don't use them anymore, because they're so much less efficient, and you just can't get as much thrust, so it's not worth it anymore. Any other questions?